All right, in this video, I'm going to be doing some example problems over a topic which you've watched a few ed puzzles on, and that is Riemann sums. So a Riemann sum, just to recap, is basically a way that we estimate the area under a curve, and we do that using rectangles. Or there is actually a case where we're going to use trapezoids, but generally rectangles. So we basically have a function. We want to find the area between the x-axis and the curve. And so we kind of simulate that by drawing these rectangles, which are shapes that we can easily find the area of. And we add up those areas, and that gives us an approximation of the area under a given curve. Now, this is kind of the foundation of what we're going to call definite integrals, where we're going to find a better approximation. But this is kind of just the beginnings of that concept. And we're going to do some basic problems today. We'll build on those and do some more AP style questions in the next video. But I just want to illustrate how you're going to do these. There's 4 ways that you can find the Riemann sum. And you're going to need to know all 4 of these. Oh, that's not what I was expecting. So there's 4 types, which we're going to go through all 4 of them: the left, the right, the midpoint, and the trapezoidal. All are similar, just slight differences in how we're going to do the computations. So let's go ahead and jump into the first one, and we're going to do all 4 of these approximations for each of these problems. So our first example, your question is going to be something like this. Estimate the area under y equals 2x minus 1 over the interval. So we're always going to need an interval. In this case, we're going to do interval 1 to 5. So it should be inclusive. We're going to do 4 rectangles. So we're going to say n equals 4. And we'll complete all 4 Riemann sum approximations. If that gets spelled. All right. All 4 Riemann approximations. Okay. All 4 Riemann sum approximations. So first thing that we're going to do is actually draw a little picture. I do want you to draw a picture for all of these. You don't have to draw separate pictures for all approximations, but I at least want you to draw a picture of this function, which we're given here, and sort of just illustrate what's happening. So the function 2x minus 1, I'm going to go ahead and just draw a graph of it. And you can, zoom in more here if you will. But I'm going to go ahead and draw this. So we are at -1. We go up 2 over 1, up 2 over 1, up 2 over 1. I realize it's not exact, but it's all right. And up 2 over 1. Okay. All right. So this is what our graph looks like. It's just a straight line. All right, it's just a linear equation. And basically what we're trying to do is find the area between 1 here up to 1, 2, 3, 4, 5. So we're trying to estimate this area under the curve. You might not understand why we'd want to do that at this point, but it is an important part of calculus. It's basically the other branch of calculus, integral calculus. So the way that we're going to approximate that is by drawing rectangles. The first illustration that we'll do is going to be the left Riemann sum. So we'll just call this the left sum. And you've already watched a few videos on how to do this, so I'll just do kind of a brief explanation. But with the left sum, basically we're going to use the left endpoints for our height. So I'm going to start here and draw a rectangle over. That will be my first rectangle. My next one, I'm going to start here, the left side, draw a rectangle over and down. The next one is going to be here, over and down. And then my fourth one starts here, over and down. So I've got these 4 rectangles, 1, 2, 3, 4. And that will give me an approximation of the area under this curve. Now this one obviously is an under approximation because we got these gaps here that are not accounted for, right? So the left sum is going to be a under approximation. And doing all of these, we had some notation using this summation. It's called sigma notation or summation notation. But basically, it's the sum of all the rectangles. So I'm just going to kind of do a little bit more basic interpretation of that. Our area is just going to be each rectangle, the width of it times the height of it, right? So another thing with the notation of these is we have something called delta x, which just represents the width. So essentially all of these rectangles are the width delta x, it's right up here. So sum of delta x times the height, because we got a width times a height. And the height is actually just the function value. So it's sort of just delta x times f of x, because we got the width here, right? And this represents the height of the rectangle. So we find all the sums of the width plus the height. The sum means you add them together. So you do the width times the height of this rectangle plus the width times the height of this rectangle. Add up all of them. That's what the summations things means. So we do need a delta x for this. For the delta x for our left, for our left and right sums here is going to be b minus a. Write this formula here. Delta x is b minus a over n. So in this case, it's going to be 5 minus 1 over n is 4. So that's just going to be 4 over 4, which is just 1. Right. So what this is saying is that our width in all of these is just going to be 1. It's pretty obvious based on this picture because we've got 1, 2, 3, 4, 5. This is a very easy basic one. Our width of all of these is a width of 1, right? And then our height is going to be whatever the function value is. So for example, our first one, our width times our height. Our width is 1 times our height. Now our height is going to be f of 1 because that's where we get the height of our first rectangle. So it's like 1 times f of 1 basically. 1 times f of 1. That's our first rectangle. Our second one, our width is 1 again, right? Times our second height, which is up here, that's f of 2. Plus our third rectangle, well, it's a width of 1, times our height, this is at 3, f of 3. Plus our fourth one, we've got a width of 1, our height is the value of 4. So plus 1 times f of 4, right? So that's basically it. We're just finding the width and the height of our 4 rectangles, and we add them all up together. So if we were to go ahead and compute this then, if you notice all of the delta x's are the same, so what we typically do is just pull that out, and then it's just essentially f of 1 plus f of 2 plus f of 3 plus f of 4, add it all together. I'm going to go ahead and just write those values. F of 1, when I plug it into my function, well, that's 1, plus f of 2, 2 times 2 is 4, minus 1 is 3, plus f of 3, that's going to be 5, f of 4 is 7. So then I just add those all up. We get 16, so it's just 1 times 16, and that's just 16. So our left sum approximation would be 16. Now if I were to do a right sum, very similar, except now I'm going to be using my right side as my rectangles. Yellow here. So my right side is going to dictate the height. So it would be right down here would be my first rectangle. Next one would be here, down and over, here, down and over, and then here, down and over. So then my rectangles turn into these yellow ones. You see in this case it's going to be an over approximation because I'm using my right endpoints. And notice that the function is increasing. Since it's increasing, if I'm using my right, it's going to be an over approximation. If it were decreasing, it'd be the opposite effect. Okay, so when I do my area here, when I sum up all the widths times the heights, my width's still going to be the same. So it's just going to be 1 times. Now instead of using f of 2 as my first height, instead of using f of 1, I'm using f of 2 as my first height. So 1 times f of 2. plus 1 times f of 3 plus 1 times f of 4 plus 1 times, my last one has a height equal to f of 5. All right, so everything's going to be pretty much the same. I can pull out the 1, and this is going to be 3 plus 5 plus 7 plus, and then f of 5, that's actually going to be 9. So when I add up all those, instead of 16, we're going to get 24. So that would be my right sum approximation. You can see there's quite a bit of difference there, right? Now, if I were to divide this into many more rectangles, let's say I did n equals 8 instead, and I did a rectangle at the midway point for all of these, I would get a better approximation because I would have twice as many rectangles. So the general rule is the more ends that you have, the more rectangles that you have, the better the approximation is. So when we get into integrals, what we're going to do is think of this as like an infinite amount of rectangles. We're adding up like an infinite amount of rectangles. For now, we're just going to stick with like 4, or you could have 6 or 8. The example problems I'm going to do, we're just going to stick with 4 for right now, so you get the idea of it. But so those are our first two, left and right. So with the midpoint approximation, it's very similar. See if I can get rid of some of this stuff here. So with midpoint, we're just going to go to the middle of each interval. So we're still going to have a width of 1. So my first rectangle is still going to have a width of 1. It's going to be from here to here. But instead of choosing the left or the right as my height determinant, I'm going to choose the middle of those two. So my height is actually going to be f of 1.5 or f of 3/2 in a sense, right? Because I want the middle between 1 and 2 is going to be determinant of my height. So you can see in this part it's a little bit over, and this part is a little bit under. So it kind of compensates. A midpoint is a way of sort of compensating between the two. So my midpoint sum is going to be 1 times f of 3/2 plus 1 times f of the middle of the next one here. We'll go up and over. So again, you can see I kind of got half of it's an under and half of it's an over, right? And the middle between 2 and 3, well, that's f of 5/2, or 2.5. My next one will be in the middle between 3 and 4, so it goes up, over, and down. And then my next one, so that's going to be f of 7/2, 3.5. And then my last one between 4 and 5, so it goes up there and over. And you can see that one's probably going to give us actually the best approximation. And we would expect it to be somewhere between 16 and 24. And that's 4.5 or 9/2. Oops, I forgot my 1 here. All right, and then since the delta x's are the same, we can just pull it out in front. And then we have just the sum of f of 3/2 plus f of 5/2 plus f of 7/2. So we would need to do those calculations. They're not bad since it's just going to be 2 times it. So it's going to be 2 times 3/2, which is just going to be 3 minus 1 is 2, plus, sorry, I should pull that out in front, plus 5/2 is going to be 5 minus 1, which is 4, plus 7/2 is going to be 7 minus 1 is 6, and 9/2 would be 9 minus 1, which is 8. So we add those together, and it's 1 times 20, or just 20. So in this case, it happened to fall right in the middle of those two, the midpoint. That won't necessarily always be the case, but since it's a linear function, it ends up being that way. All right, now the trapezoid is a little bit different. Those three are very similar. The only thing that really changes is how we're choosing the height. So what f of value we're choosing. With the left sum, we start on the left side, and we don't include the sort of the ending. With the right sum, we don't start exactly on the left side, but we do include the ending or the sort of the far end of the interval. So since the interval was 1 to 5, notice the left sum we started with f of 1, right? But we did not have an f of 5. With the right sum, we ended with f of 5, right? But we did not have an f of 1. So that's kind of a way you can check. And since it's n equals 4, you should have 4 values for all of these. You can see there. Same with the midpoint, we've got 4, and we're just choosing the middle between those two. So between 1 and 2 is 3 halves. Between 2 and 3 is 5 halves, so on and so forth. So hopefully that makes sense to you. But let's go ahead and do the trapezoidal sum. So for trapezoidal, first of all, I want you to think about what is the area of a trapezoid. Because if we're going to divide this thing into trapezoids, I'm going to go ahead and kind of illustrate that. That's actually going to be the best approximation for this one. The reason why is trapezoids, I can draw like this. So I can have sort of a slanted edge like that, right? And then my next one, I can go up and have a slanted edge like that. And then I can go up, a little bit off there, slanted edge there, and up, slanted edge there. So I've got my 4 trapezoids here. And that's actually going to be a perfect approximation for this because it's a linear function. It doesn't always work that way. But this actually will work really well. And with this trapezoid, so if I were to just sort of pull one out, looks like this. That's a trapezoid. If you remember, the area of a trapezoid is 1/2 b1 plus b2 times the height. So essentially what I'm doing is I'm taking that one out, and if I were to sort of flip it sideways, it makes a little bit more sense if I were to flip it that way. Just kind of rotate it. I've got my height, which represents this here, okay? And this is sort of my b1 and my b2. So my height is actually the delta x. That's actually the width, because that's this part right here, right? You can see. So the height is actually delta x. The 1/2 obviously is just 1/2. My b1 and my b2, well, b1 is represented by this part, which is actually f of 2 in this case, if you can see that there. And then b2, and you can use this interchangeably, represents this height here, which is f of 1. So essentially, in this one, it's just like 1/2 of f of 1 plus f of 2 times my delta x. So if I were to translate that over here, all my areas, my first one is going to be 1/2. It's the first one we just did. F of 1 plus f of 2. So essentially, we're just taking both of those rectangle heights, if you will, right? Taking the average of them times my height. My height is the delta x, is actually the width, if you will. Okay, and that's just 1. So that's 1/2 b1 plus b2 times the height. All right. My next rectangle, choose a different color here. Or sorry, my next trapezoid is going to be here to here, up and over. I've got sort of the same deal here. It's going to be 1/2. And my 2 bases are going to be f of 2, my shorter one, and f of 3 is my taller one. So f of 2 plus f of 3 times my height, if you will, which is in this case the width of the interval there, which is 1. Okay, my next one, 1/2. And for my next rectangle, my first base is going to be 3 f of 3, and the second one's f of 4. So it's going to be 1/2 times f of 3 plus f of 4 times my height, if you will, which is 1. All right, and then my last one is going to be f of 4 as my b1 and f of 5 as my b2. So plus 1/2 times f of 4 plus f of 5 times the height, which is, again, 1. So here's my 4 trapezoids. It works the same way. It's just we're kind of taking the average of the height values. The midpoint takes the average of the x values. So it takes the average of the widths, if you will, of widths. I guess you can kind of say. Finds, well, it takes the average of the heights using the width. And then the trapezoid kind of takes the average of the heights using the heights, if you will. Hopefully that makes kind of sense. Midpoint takes average of the heights using the widths, takes the middle of the x, and the trapezoid sort of averages the y values. They both accomplish similar things. All right, so let's go ahead and do this computation. So this, notice all of these have a 1/2, and they also have the same 1 here, right? So essentially what we do is we pull out the 1/2 and the delta x. So that's just going to become 1/2 times 1 is obviously just a half. So that 1/2 can pull out. And then you'll notice a couple other things here. The f of 2 is repeated twice, right? F of 3 is repeated twice. F of 4 is repeated twice. Now f of 1 and f of 5, the endpoints are only occur once. So you'll see some notations where they basically say, the first one is only once and the last one is once, and all the other ones you just do 2 times it. So this is just going to turn into f of 1 plus 2 times f of 2 plus 2 times f of 3 plus 2 times f of 4 plus f of 5. So always your middle ones are going to get multiplied by 2, and then your endpoints, we just use the height of those one time. The middle ones occur twice because you're using sort of those base heights twice because you use it for once and then you use it for the one next to it as well. So all the middle ones are multiplied by 2. Just simplifies a little bit. You don't have to do it that way. There's also some notation. Don't worry about that too much. Just we need to understand the concept of what we're doing here. So let's go ahead and just do this computation. 1/2. Then f of 1 was 1 plus 2 times f of 2 is 3 plus 2 times f of 3 is 5 plus 2 times f of 4 is 7 plus f of 5, which is 9. So we'll do all that. 1/2 times 6 was 10 is 16, 17, 21, 31. So we get 40. Yep. So 1/2 times 40, which is 20. All right. So that would be our trapezoidal approximation. If you were asked a question about which is the best approximation, you can see midpoint and trapezoidal are both the best two. They also require the most work, but those would be our best 2 approximations. They actually both give you the exact answer. If I were to actually do the integral of this, the exact answer would be 20. So kind of looking ahead, when we're finding the area using an integral, what you do is you put the endpoints on the top and the bottom of the integral there, and then you write the function, and then you basically integrate this. And then, so the integral of this would be x squared minus x, and then you evaluate it. So you're going to plug in your 5 and your 1 and evaluate it, and you'll end up getting 20. I'll show you that in a few videos, but that's called the fundamental theorem of calculus. So, all right, let's go ahead and look at our second example. I know that one took a long time. Let's at least look at one more here. We'll go a little bit faster through this one. All right, so our second one, let's do, we'll do y equals 3 minus x squared. We're going to do the interval -1 to +1 and n equals 4. And we're going to do all 4 approximations. So I'm going to draw a little illustration. This one is an upside down parabola, shifted up 3. So it goes like this. And for this one, we're looking on the interval from -1 to +1. So we're looking at the area from here to here. All right, so first one, let's go ahead and start with our left sum. And actually, let's go ahead and write delta x as well. It's a good idea to just go ahead and do delta x for all of them first. So delta x is b minus a over n. So that's going to be b here is 1, a is -1, so 1 minus -1 over 4. That is 2 over 4, which is a half. So all that tells us is that the width of each of our rectangles should be 1/2. Right? So my first rectangle, second, third, you can sort of view it like this. Each of these rectangles are going to have a width of a half. And that should make sense because we only have sort of a width overall of 2. So if I'm going to divide that into rectangles, each of those are going to have a width of 1/2. My first one for the left sum is going to go up here. And then we're going to go over to 1/2, right? Negative a half, and down. My next one is going to go up here, over and down. And then we're going to go up here, over and down, and then up here, over and down. I've got my 4 rectangles. I know those aren't exactly the same width. They're supposed to be. I just didn't draw them exactly right. So for my left sum, my delta x is a half. So with this one, I'm going to go ahead and just pull out that 1/2 because we know what's going to happen. All right. And then my first height, my first rectangle, is going to be, since the left sum, I'm going to use my left sort of endpoint of my interval. So f of -1 plus, and then I'm just going to add delta x to that. So my next height is going to be f of -1/2. Oops. And then I'm going to add half to that, and then my next height is going to be f of 0. And then I'm going to add a half to that, so then my last height is going to be f of 1/2. So there's my 4 rectangle heights. This is the width, and this represents the 4 heights. And again, I just pulled out the width because it's going to be the same for all of them. All of these would have a 1/2 attached to them. But since the width is the same, I can just pull that out. Now, there'll be scenarios when we look at like some tables and other applications of AP questions where you can't necessarily pull out the width. So it's good that you understand both of them, that this width is applying to all of them. But for these problems, since we're doing equal intervals, we're going to just pull the width out in front. That'll simplify things for you a little bit. All right. So then let's go ahead and evaluate this. So it's going to be 1/2 times f of -1. That's going to be 2. F of -1/2. That is going to be, if you want to plug it in here, you can do that on the side. 3 minus -1/2 squared. Well, you square a half, you get a fourth. So 3 minus 1/4. You want to change 3 into fourths, which is 12/4. So 12/4 minus 1/4, which is 11/4. You should be able to do that computation on your own without a calculator. The AP test will expect that you can do that. So hopefully you can do that. So we got 11/4 plus f of 0 is just going to be 3 plus f of 1/2 is going to give you the same answer, 11/4. So we need to add all of those up. We're going to need to convert these to fourths in order to make that work. So 2 is equivalent to 8/4. 3 is equivalent to 12/4. So we've got 19, 21, 31, 42/4. I did that right? Hopefully. Just double check that. 19. Yeah, it should be 42/4. All right, 42/4, and then times a half would be 42/8, which would reduce to 21/4. And that's, again, the way that you should write that on the AP test. All right, let's do our right sum. This will get easier and easier the more that you do. So the right sum, we're choosing this as our height over, this is our height over, this is our height. That one will be a little under, and this one will be a little bit over. So you can see like 3 of these rectangles are over approximations and 1 of them is an under approximation. Where with the left sum, 3 of them were under and then 1 was over. It's going to work very similar. We're going to pull the 1/2 out in front. But now instead of starting with -1, we're not going to start there. We're just going to start with the next one that we had. We're going to add delta x to it. So that's going to be f of -1/2. And then plus f of 0. After you do the first one, the next ones are really pretty easy, at least the left and the right. So we got -1/2, 0, 1/2, and then plus. And then this one we should be ending with our endpoint, which is +1. So f of 1. So everything's sort of just shifted down a half. And then from there, f of -1/2, we already did that computation. That was 11/4. F of 0 was 3. F of 1/2 was 11/4. F of 1, well, plug that into our original equation there. That's 2. All right, so then we just need to add all those together, convert them to fourths again. 11 fourths plus 12 fourths plus 11 fourths plus, 8 fourths. So add those all together. It looks like we get 20, 30, 40, 42, I believe. 42 fourths. It's 42 over 8. And that is 21 over 4. So we actually get the same answer. Even though some of the rectangles ended up having more under and more over, they kind of even each other out based on, I guess, the one over from the one scenario kind of compensates for the other 3 unders, and so on and so forth. All right. So next one we need to do is a midpoint. So midpoint is going to be just a little bit more challenging on this one. The middle of these intervals, I was just like try to find my first one. The middle there between -1/2 and -1 is -3/4. So you kind of just gotta have to find your starting spot, which is -3/4 in this one, the middle of those first two. And then so our next one is going to be -1/4, and then +1/4, and then +3/4. So those are going to be the heights that we're going to use. We're just adding a delta x. So it's like plus delta x, plus delta x, plus delta x. We're just adding a half to all those. So we find the middle of our first one, and then we just add a half to those. But it works the same way. We're going to pull the delta x. We can still pull that out because it's still a half. And then it's going to be f of -3/4 plus f of -1/4 plus f of +1/4 plus f of 3/4. And we're going to be adding all those together. So f of -3/4, that's going to be 9/16. So we'll just do one of them here. 3 minus, so it's going to be 3 minus 9/16. Oops. So we need to change the 3 into 16ths. So that's going to be 48/16 minus 9/16. So that gives you 39/16. So this one gets a little bit messy. And then with the 1/4, that's 1/16. So it's 48/16 minus 1/16. So that's going to be 47/16. And then +1/4 will be the same, 47/16. And then +3/4 will be the same as the -3/4 of 39/16. So let's add all those together. Do the math here. 39 times 2, 47 times 2. We get 172/16. And reduce that. Looks like 72 divided by 8. Now 172 divided by 4 works, I think. Yeah, so it'd be 43/4. All right, and our last one, trapezoidal sum. You do need to make sure you're showing some of your work, so at least showing like this step here. It'd be good if you showed a lot of work, but you need to at least be showing this step. All right, so trapezoidal is similar. Remember in that one, we can pull off the 1/2 because all of them have the 1/2 b1 plus b2 times the height. We can also pull out, so this represents sort of the width, if you will, right? And we can also pull out the 1/2 just that's in the formula. So our width ended up being, our delta x was a half in this, and our 1/2 from the 1/2 b1 plus b2 times h. So that 1/2 pulls out. And then this also pulls out as well because it's 1/2. So we actually end up with 1/2 times 1/2 that we're pulling out. And then we've got each of our B1 plus B2s. So the B1s, I'll go through and just do this one. But our first one was is going to be f of -1 plus f of, and then it's going to be -1/2 is our sort of our first B1 plus B2, right? And then it's like plus our next B1 plus B2 would be f of -1/2 plus f of 0 for our second one. Our third one, f of 0 plus f of +1/2. And our last one, f of +1/2 plus f of 1. So again, if we were going to write out each one of these, it would be like sort of 1/2 times f of -1 plus f of -1/2 times our height of 1/2, right? And then the next one would be 1/2 times f of -1/2 plus f of 0 times 1/2. And all of these are going to have 1/2 there twice, so we're just pulling both of those out. So that makes 1/4. And then remember how all of these middle ones get repeated twice, right? So there's 2 of these, there's 2 of these, there's 2 of these. So we're just you can just write this as 2 times those. So really we end up with f of -1 plus 2 times f of -1/2 plus 2 times f of 0 plus 2 times f of +1/2. And then plus our ending is just 1 times, like the first. So that's how it all shakes out. We go through and do the math on this. We should have all these calculations already done. F of -1 is 2 plus 2 times f of -1/2, which is 11/4, plus 2 times f of 0, which is 3, plus 2 times f of 1/2, which is 11/4, plus f of 1, which is 2. So pull those together. All right, let's crank out some math here. So we get, I'm just going to turn all of these to fourths. So this would be 8/4 plus 22/4 plus, that's going to be 6. So it'd be 24/4 plus 22/4 plus 8/4. And let's add all those together. We get 84/4, so 1/4 times 84/4. 84 is actually divisible by 4, it's 21. So that just ends up 1/4 times 21, or 21/4. And that was the same as our left and our right. Seems like I did something wrong on the midpoint there. What did I do wrong? I don't know. The midpoint I think should have been the same. I'm not sure what went wrong on that one, but maybe I'll go back and check that after I finish the video, because this is dragging out. I know it's a long time, so I'm sure I messed up on the midpoint there. Go through and check those calculations. I'll probably figure out what I did wrong there, because it shouldn't be 43/4. It should be probably 21/4 or similar. All right, so let's look at the last one. That's a long video, but I do want to show you one with a trig function. So number 3, I actually had 4 problems mapped out, but I think 3 will probably be sufficient. It's going to be y equals cosine of x. The interval we're going to use here is -π/2 to +π/2, and we'll stick with n equals 4. So I want you to do a sketch. The cosine function looks like this, right? But we're talking about -π/2 to +π/2. So it's actually going to go sort of there. And cosine actually crosses here at π/2 and -π/2. So find the area in between there. And we're going to do our left or right and our trapezoid and our midpoint. So for our left, We still do delta x, so that's going to be b minus a over 2. So it's pi over 2 minus negative pi over 2 over 2. That becomes a plus. It's just essentially a half pi plus a half pi, which is a whole pi. So our delta x is pi over 2, which should make sense because if I'm dividing this up, we've got, sorry, that should be 4 on the bottom, not 2. Sorry about that. If I'm dividing this up, it should be divided into fourths. So this would be negative pi over 4. This would be 0, positive pi over 4, and then this is 2 pi over 4, or pi over 2. All right, so for my left one, notice my left one, I'm actually have a height of like 0 on this first one, right? And then the second one would be over here. The third one would be up here. And then my last one would be here. And then with the right sum, it's just going to be flip-flopped. It's going to be the opposite. So my left sum, my area is going to be my delta x. I'll pull out in front, which is pi over 4. And then I'm going to be starting with the left one. So it's f of negative pi over 2 plus f of negative pi over 4. I'm just sort of adding a delta x to it, plus f of 0 plus f of pi over 4. So those are my 4 heights. And that. So the height at negative pi over 2 is just going to be 0 plus f of negative pi over 4. That's actually going to be radical 2 over 2. Not the most lovely thing, but if you remember from the unit circle, at all the pi over 4s, 3 pi over 4s, those are always radical 2 over 2, comma radical 2 over 2. You can remember that. F of 0 is going to be at 1. Height is up there at 1, the height of the cosine function. And f of pi over 4 is also going to be a radical 2 over 2. So the best way to simplify this thing. We can add those radical 2 over 2s. So it's like 2 radical 2 over 2, if I combine those, plus, if I turn this into half, it would be 2 over 2. And well, the best way to simplify this, let's say, I guess it'd just be 2 plus 2 radical 2 times pi over, so if I combine those, it would just be 2 radical 2 plus 2 over 2 over 4. Multiply it. And I suppose, yeah, there's probably a way you could simplify that more, but that's okay for now. I guess you could like pull the 2 out maybe. We get 1 plus radical 2 times pi over 4. And simplify that would be 1 plus radical 2 times pi over 2. It's probably the simplest way, or pi plus pi radical 2 over 2. Just make sure you know how to rewrite things. The AP test might have the answer written in a number of different ways if it was a multiple choice. So any of those would work. I'm going to do the right. Riemann sum works very similar. Get my delta x pulled out in front. My first one is going to be f of, just going to start with the second one here, f of negative pi over 4 plus f of 0 plus f of pi over 4. And then I'm going to be ending with the b pi over 2. And I believe we'll get the same exact answer. If you do all those, it's going to be radical 2 over 2 plus 1 plus radical 2 over 2, and then plus 0. It's just going to be ordered differently. So you're going to get the exact same answer as this. Same answer. So I won't need to go through that. The next one, the midpoint. Let's go ahead and do that one. So I'm going a little bit faster on this one. For the midpoint, delta x is still the same, pi over 4. And then we have to choose the midpoint of those. So this might get a little bit sticky here. The midpoint between those is actually the middle of pi over 2, or negative pi over 2, and negative pi over 4. The way you could do that is you could add them together and divide it by 2 to find the midpoint. When you do that, this would be, negative 2 pi over 4 plus negative pi over 4 over 2. So that's going to end up with negative 3 pi over 4 over 2. You flip it and multiply, you get negative 3 pi over 8 is the midpoint there. Negative 3 pi over 8. So that's going to be my first height, negative 3 pi over 8 plus my next height. What you do is you add delta x to that. So if you add a pi over 4 to that, that's the same as adding 2/8. So that's going to be f of negative pi over 8, just negative 1 pi over 8. And then add 2/8 again, we get f of positive pi over 8. And then my next one is going to be f of positive 3 pi over 8. So those are going to be the ones we're going to evaluate. Those values, I suppose you could just do decimal approximations for that. I'm not going to do that just in the sake of time and you wanting to watch a video. So that's how you would do that one. Trapezoidal. So for this one, we always pull out the 1/2 and then the delta x as well. Our delta x is pi over 4. So those two just pull out. And then we would, going to just try to show you the simplified version of this one. So the first one we just do once. So that's going to be f of negative pi over 2. So we kind of just start with the beginnings of the left, which is negative pi over 2. And then the next one is negative pi over 4. That's going to be twice, plus 2 times f of negative pi over 4, plus 2 times f of 0, plus 2 times f of pi over 4. And then we end with the last one as just once. That's f of pi over 2. Notice with the trapezoids, there's always one more value than we want. Then there's ends. There's 5 values. The middle 3 are repeated twice. The end ones are just once. So those kind of accumulate for 1, and then we're taking half of it. So we still have the same amount of shapes. So when we evaluate this would be pi over 8 on the outside. And you could do all these values just from up here, right? That'd be 0 plus 2 times radical 2 over 2 plus 2 times 1 plus 2 times radical 2 over 2 plus 0. So for that, pi over 8 times, these get canceled, so it just actually ends up being 2 plus radical 2. And suppose you would simplify it. I think you get the same answer. But all right, I know that's a lot. I just wanted to make sure you saw all 4 of those and got the gist of how you're solving these. If you still are confused, by all means, please reach out to me. I know this is a lot going on. It's a lot to cram into one video. So reach out to me if you do still have questions. Thanks.